The night sky stretched out like an endless ocean of darkness, where stars burned quietly in the frozen void. Amid that silence, Earth drifted like a small, lonely stone across the cosmic sea, believing itself to be the only watcher. Yet sometimes, in those rare moments of the universe, a strange light sweeps across the heavens, as if the sky itself had just sighed. In 2025, among billions of wandering worlds, humanity discovered an uninvited guest, an icy traveler rushing in from farther away than anything we've ever known. It didn't belong to the sun, nor was it bound by any gravity within our system. Astronomers gave it a simple name, Three-Eye Atlas. But behind that simplicity hid something profound. Three, because it was the third visitor from beyond the solar system, and Atlas, the giant who bore the weight of the heavens. When its light first touched the lenses of our telescopes, an odd stillness swept through the scientific world. A quiet, uneasy feeling, as if the universe had just whispered something. It came in silence, gliding through space without warning, and in that fleeting moment, everything humanity thought it knew about its place in the cosmos suddenly felt fragile. If the stars are the eyes of the universe, then that night, one of them blinked. And for the first time, humanity began to wonder, are we still the ones doing the watching? July 2025. In the arid heart of Chile's Atacama Desert, where the night sky is so clear that the Milky Way seems to spill onto the ground like a silver ribbon, astronomers from the Atlas Project work in silence. Beneath a dome of cold steel, dozens of mirrors sweep across the heavens, searching for wanderers in the dark, asteroids that might one day cross Earth's path. Everything moves with quiet precision, rhythmic and mechanical, like the breath of some vast metallic creature. Then, a single point of light appears. Faint, small, but different. It doesn't move like the countless objects they've tracked before. Instead of tracing a closed loop around the sun, it follows an open curve, as if just passing through the solar system, never to return. The first calculations make no sense. Its orbit cannot close. It will come, and then it will go, forever. In that instant, the scientists realize what they are seeing. This isn't an ordinary asteroid. It's a visitor from beyond our solar system, the third one humanity has ever known. As the data spreads to observatories around the world, the stillness of Atacama dissolves into a wave of invisible excitement. From NASA's control room in California to the observatories of Mauna Kea and La Palma, every telescope turns to the same patch of sky. Pan-STARRS, ALMA, even the James Webb Space Telescope are all brought online. Within hours, the night sky becomes a web of enormous eyes, all focused on a single drifting point of light. The first spectrographic data arrives. The reflected light suggests ice and dust, possibly a comet, but something feels off. The signal flickers in a strange rhythm. Analysts notice that even with such an open orbit, the object's velocity is nearly twice what physics would predict. At 130 kilometers per second, it's far faster than any known comet, beyond what our current models can explain. A low voice breaks the tension during a video call between NASA and the European Space Agency. It trembles slightly, caught between awe and disbelief. We've seen Oumuamua, then Borisov, but this isn't like anything before. It's coming from nowhere, from a void that doesn't belong to any star. Silence follows for nearly a minute. Outside, the desert wind stirs the sand. Inside, a chill runs down every spine. Not fear, but the humbling realization that they might be eavesdropping on a conversation between the stars. From the first images, Three-Eye Atlas looks like a classic comet, an icy core, a shining tail trailing in sunlight. But the more they observe, the stranger it becomes. Its optical reflectivity barely changes, no matter the angle. Ordinary comets spin and flicker as light bounces unevenly off rough surfaces. This one doesn't. It gleams, seamless, like a mirror. At first, scientists call it coincidence, an illusion of perspective or data error. But deep down, many sense something else. A physicist from the German Space Research Institute writes in his journal, "It doesn't glow like a comet. It reflects, as if returning our gaze." Night after night, telescopes gather more data, sending hundreds of gigabytes back to Earth. NASA gives it a temporary designation, Three-Eye, Interstellar Object 3. Then, to honor the observatory that first spotted it, they add a name, Atlas. Days later, an emergency meeting convenes at the Jet Propulsion Laboratory in Pasadena. In a dimly lit room, frames of the object flicker across the wall. Orbit specialists point to graphs. Atlas's trajectory cuts through the plane of the ecliptic at a 54-degree angle, coming from the direction of the constellation Lyra, a region with no bright stars nearby. That alone is baffling. Interstellar objects are usually flung from crowded systems, tossed free by powerful gravitational slingshots. But Atlas shows no trace of such origins. It comes from emptiness. Maybe it was thrown out by an ancient collision in a system that no longer exists, someone suggests. Or, another voice answers slowly, maybe it never belonged to any system at all. The room falls silent. Beyond the glass windows, the California night glows with city lights, yet somehow, those lights feel distant. When news of 3I Atlas reaches the public, curiosity ripples across the world. Scientific journals, physics forums, social media, everyone asks the same question. Could it be artificial? It's not a new question. Back in 2017, when Oumuamua was discovered, astrophysicist Avi Loeb stirred controversy by suggesting it might be an alien probe. The scientific community dismissed it as speculation. But with Atlas, that memory resurfaces, sharper this time, because the data is too strange to ignore. Teams at Harvard begin running dynamic simulations. In Paris, the Institute for Celestial Mechanics analyzes the reflected light. The results don't agree, but all point to the same unsettling conclusion. Atlas doesn't behave like a natural comet. Meanwhile, the Chilean sky remains unchanged. Observers keep watching, tracking that faint point of light drifting steadily, almost deliberately. One night, during a late shift, a young researcher stares at the live feed as the software logs the object's position. On the orbital chart, its path cuts delicately through the solar system, a graceful curve between two voids. She murmurs, half joking, "It looks like someone just drew a question mark across the sky." No one responds. The only sounds are the hum of fans and the quiet tapping of keys as green monitor light paints their faces. When the last data of the night is saved, a moment of stillness lingers before the screen fades to black. Somewhere in the depths of space, that object keeps moving, leaving no trace, sending no signal, reflecting only the light of distant stars. Like a cosmic mirror, it reflects not just light, but humanity's gaze itself. And as the desert night closes, the sky remains calm, as if nothing happened. But deep within human knowledge, a small fracture has opened, a crack of doubt, a question without an answer. Is the light we're watching us back? In the days following the discovery of 3I Atlas, data from observatories around the world began to converge like streams of light, forming a roaring river of information, all flowing toward a single point. The James Webb, Hubble, Pan-STARRS, and ALMA telescopes all turned their gaze to one tiny coordinate in the sky, where a cold, silent object was slicing through the solar system like an arrow shot from the ancient past. And then the first numbers came in. Numbers that made the entire astronomical community stop in its tracks. Its speed, 130 kilometers per second. So fast that no natural object within the solar system could ever reach it. It raced past Jupiter through clouds of gas and dust without slowing down. That velocity was enough to escape the sun's gravity entirely. Not just to leave, but to leave forever. Its path wasn't a closed loop, but an open curve stretching into infinity, never turning back, belonging nowhere. When scientists looked at the trajectory, they didn't just see a moving object. They saw intent, as if Atlas hadn't been thrown, but sent. Then came the chemical data, the part that revealed its soul. Using the most sensitive infrared spectrometer humanity has ever built, the James Webb Telescope detected something absurd. Carbon dioxide made up 81% of its gaseous envelope, tens of times higher than any known comet. Water ice, the defining feature of comets, was almost absent. Water vapor, if present at all, appeared only in trace amounts, far below what any existing model could explain. Some researchers suggested that Atlas might have formed in the ultra-cold outskirts of the galaxy, where cosmic radiation could have altered its molecular structure over billions of years. But others shook their heads, because even in the universe, extremes have limits, and 3I Atlas seemed to have crossed them. In NASA's data center, under the dim light of the control room, the spectral lines on screen began to morph into a portrait of confusion. The red line representing CO2 spiked upward like a crack running through everything we thought we knew. A scientist whispered, unable to hide the awe in their voice, "If this is real, it's not just a comet. It's something chemically different, something that shouldn't exist in nature. But what silenced the room wasn't its chemistry, it was its age. Carbon isotope spectroscopy and radioactive decay measurements revealed that the material composing 3I Atlas could be older than the Sun itself, beyond 5 billion years, possibly 7 or 8. That meant it formed before the solar system, before Earth had oceans, even before the Milky Way took its present shape. It was a relic of the primordial cosmos, a shard of the early universe drifting through hundreds of thousands of light years. Now, by some impossible coincidence, passing near the cradle of life it never belonged to. At a press conference, an astrophysicist from the Kavli Institute in Cambridge said softly, "If it's truly that old, it carries the history of the universe, from before we even existed." The words echoed, quiet but cold, like a prayer whispered in the cathedral of science. For a moment, the entire room fell silent. Graphs, numbers, models, all faded into stillness, leaving only pure astonishment. But wonder quickly turned to doubt. Every time they tried to explain, the data betrayed them. When calculating its orbit, Atlas behaved like a comet, but didn't produce enough dust to form a tail. When analyzing surface temperature, it reflected light like a metallic object, but showed no trace of iron, nickel, or any alloy. And its material decay rate was unnaturally stable, as if refined by a process nature itself would never follow. A senior ESA researcher wrote in a confidential report, "If we assume 3I Atlas is natural, we'll have to rewrite everything we know about comets. If it isn't, then we're looking at something that was made." Those last words, "was made," fell like a spark into an ocean of doubt. No one wanted to say it aloud, but the thought had already taken root. Through long nights at observatories, scientists stared at screens where Atlas appeared as a solitary point of light. It emitted no radio signal, no detectable wavelength. It simply drifted, steady, unwavering, as if following a purpose beyond human comprehension. Some began recalling Oumuamua, the first known interstellar visitor, discovered 8 years earlier. Back then, its unusual acceleration had hinted at some hidden mechanism. Now, Atlas brought those memories back, but this time with stronger, deeper, and far more unsettling evidence. Across astrophysics forums, a question spread like a cold wind. Could there be, among the stars, artificial objects adrift for billions of years, remnants of ancient civilizations, ships lost in the cosmic night? No one had an answer. But deep down, the feeling grew, equal parts wonder and fear. At NASA's Control Center, amid a forest of data screens, 3 orbital plots were placed side by side: Oumuamua, Borisov, and Atlas. The difference was unmistakable. Atlas didn't rush through space like a wanderer. It moved with a strange steadiness, almost deliberate. It didn't speed up, didn't slow down, maintaining a perfect rhythm through every distance. Physicists tried to reason it out. Maybe its internal mass distribution caused the stability? Maybe it contained ultra-solid CO2 ice that held its shape? But every theory crumbled before the data. No velocity fluctuations, no gas jets, no rotational wobble. A silent object, stable, unyielding, not spinning, not breaking down, just gliding through perfect stillness. An astronomer at JPL murmured, almost to themselves, "Maybe it isn't bound by the sun because it never belonged to any star." That sentence ended the meeting. No one responded. Only the hum of the air conditioner, the soft clatter of keyboards, and a silence as thick as the space between stars. Outside, 3I Atlas kept drifting, hundreds of millions of kilometers from Earth, reflecting the sun's light with a cold, glass-like shimmer. It sent no signal, carried no message. Its very existence was the message, etched into human awareness by that faint, distant glow. Maybe it's just an ancient rock, a silent witness to cosmic time. Or maybe, within its frozen core lies something else. A structure not born of nature, a memory launched long ago by a civilization that vanished before Earth even lived. Whatever it is, 3I Atlas has planted a thought in the human mind. Sometimes, the most terrifying thing isn't that we don't understand the universe. It's when the universe starts to look too precise, too deliberate, as if someone, somewhere, had once touched it. As 3I Atlas drifted through the quiet space between Jupiter and Mars, an unprecedented global observation campaign unfolded. More than a dozen observatories turned their telescopes toward the same point in the sky, as if humanity itself were focusing every gaze on a lone soul adrift in darkness. Inside control rooms lit by the soft blue glow of monitors, scientists watched every tiny shift in its orbit, every faint flicker of reflected light. They weren't just studying an object. They were searching for an answer to something beyond human understanding. The Hubble Space Telescope was among the first to capture clear images of Atlas. From its orbit around Earth, it recorded fluctuations in brightness, rhythmic yet irregular, like the uneven heartbeat of a sleeping creature. Ordinary comets reflect light in sync with their rotation, but here, every rhythm broke apart. No cycle repeated, no pattern emerged. Its brightness rose and fell unpredictably, as if its surface were changing in ways no one had ever seen before. Meanwhile, the James Webb Telescope, humanity's farthest-seeing eye, began scanning the object's infrared spectrum. The results left researchers speechless, a light signature that didn't match any known chemical model. Some spectral lines hinted at solid carbon dioxide, but interspersed among them were faint, unfamiliar frequencies, so weak they could have been dismissed as noise, yet persistent, repeating over and over. These signals didn't correspond to any natural molecule. They seemed structured, as though they came from something deliberately arranged. At the ALMA Observatory in Chile, scientists tried to detect Atlas in millimeter radio waves. They expected to see thermal emissions, or at least static from evaporating ice. Instead, the spectrum on their screens was flat. No signals, no oscillations, no whispers across the void. Only perfect, absolute silence. To the scientific community, that silence spoke louder than any sound. Inside NASA, opinions began to divide. The majority insisted that silence meant nature. They argued that Atlas was an ancient comet, long since stripped of its volatile materials, no longer emitting radio waves like younger ones do. The strange data from Hubble and Webb, they said, could still be explained by chemical variations in its formation environment. To them, 3I Atlas was a relic, an eroded fragment of the early universe. But not everyone was convinced. A smaller group, made up of theoretical physicists, signal analysts, and SETI researchers, saw the silence as something far more unsettling. They believed that perfect silence could be a strategy, a sign of intent. In the cosmos, every natural object emits something: heat, radiation, motion. Only one kind of object stays completely quiet, one designed not to be found. A researcher at the SETI Institute wrote in a report to NASA, "Silence is not evidence of absence. It may be evidence of presence, just hidden in plain sight." That idea made many uneasy. It awakened an old fear that humanity might no longer be the only observer of the sky. Meetings grew tense as each side defended its theory with charts, models, and equations. But beneath the data, a deeper feeling spread. Something didn't add up. In one internal report, the Hubble team noted a strange correlation between Atlas's reflected light and Earth's line of sight. The object appeared to subtly adjust its brightness depending on the viewing angle from our planet. At first, analysts dismissed it as statistical error, but after reviewing hundreds of observations from other telescopes, the pattern remained. Atlas seemed to brighten whenever Earth was watching, and dim when it wasn't. An ESA expert finally said during a meeting, "If that's a coincidence, the odds are astronomically low. And if it isn't, then it means it knows we're looking." The room fell silent. But science runs on evidence, not fear. So a new, massive listening campaign began. Radio telescopes across the world, from Green Bank in the US to FAST in China, turned their antennas toward Atlas, scanning every frequency between 1 and 12 gigahertz. They hoped for even a single anomaly, a patterned fluctuation, a structured signal, anything. But all they found was nothing. No signal, no variation, only the soft background hum of the cosmos, lonely photons drifting through the dark. And in that emptiness, a question began to form. What if 3I Atlas isn't transmitting? Because it doesn't need to. An object advanced enough might hide in absolute silence, observing and listening. No radio waves, no heat signature, no trace. With technology beyond imagination, it could communicate through means unknown, magnetic fields, neutrinos, or perhaps through the geometry of its own orbit. Physicists began to think bigger. If 3I Atlas were a piece of technology, it might have existed for billions of years, requiring no power, no repairs, drifting endlessly like a cold, unblinking eye. A probe, perhaps, the kind philosopher Freeman Dyson once described, eternal machines quietly passing through civilizations, recording, never intervening. At NASA's Ames Research Center, one physicist mused in a private interview, "Maybe it didn't come for us. Maybe it's just passing by. But the thought that it might know we're here, that's enough to make us rethink ourselves." Night after night, observatories kept their eyes on the sky. Atlas continued its steady path, no deviation, no dimming. A small point of light, yet enough to unsettle an entire species' sense of place in the universe. When the campaign finally ended, no conclusions were drawn. Atlas remained a perfect mystery, too cold to be a normal comet, too stable to be random debris, too silent to be coincidence. And buried in the dry pages of the final report, a single handwritten line from an old astronomer remained. If someone sent an eye into the universe, an eye that never blinks, would we even know when it's staring right at us? As 3-Eye Atlas drifted farther into the dark, the sky fell quiet once more. Yet within that calm, humanity couldn't shake the feeling that something unseen was still watching. Not with light, not with sound, but with its very existence. An existence that made both science and philosophy bow their heads, realizing, if only for a moment, that sometimes the greatest truths are not in what the universe says, but in what it chooses not to. As 3-Eye Atlas drifted closer to the sun, its orbit began cutting through the illuminated plane of the solar system. Light reflected from its icy surface suddenly intensified, glowing 4 times brighter than predicted. The change couldn't be explained by any known physics. There were no outgassing jets, no vapor trails curling up from melting ice. The sun wasn't evaporating it, only making it shine, as if the light weren't reflected, but born from within. At first, astronomers thought it was a measurement error, a glitch in the system. But when other observatories confirmed the readings, a heavy silence spread through the research community. In science, every phenomenon must have a cause. Yet Atlas seemed to be defying that rule. Inside NASA's control center, hundreds of monitors streamed real-time data. Physical models were built and erased, hypotheses formed and collapsed. The thermal output didn't match the reflected brightness. The energy it emitted far exceeded the sunlight it received. Then, in a tense meeting, a particle physicist muttered the words that froze the room. "It's glowing by itself, not because of the sun, but because of itself." What sounded like mere speculation left a lingering unease. If that were true, Atlas possessed an internal energy source, a mechanism for generating heat independent of external radiation. And in the known universe, only 2 things could do that: radioactive decay or technology. Spectral readings from the James Webb Space Telescope soon revealed something stranger. Atlas's light wasn't constant, but pulsed in rhythmic intervals. When plotted on a graph, the oscillations formed neat, repeating peaks, precise to the minute, too stable to be random. A team of engineers studying the frequency patterns remarked, "This doesn't look like a comet's rotation. It looks modulated." Light waves, once considered purely natural, now carried the rhythm of intent. NASA swiftly released an official statement. There is no evidence that 3-Eye Atlas is an artificial object. The announcement was broadcast worldwide, meant to calm the public and shield scientists from a flood of speculation. But behind closed doors, the quiet voices of theoretical physicists lingered, cautious yet haunted. "If a civilization wanted to observe us," one whispered, "this would be the perfect way. A messenger disguised as a comet." Silence was no longer emptiness, but invitation. At Harvard's Center for Astrophysics, a small group began exploring the idea through the lens of quantum mechanics. They proposed that Atlas might contain an artificial nanostructure, a carbon lattice capable of absorbing and re-emitting light in precise cycles. A kind of quantum antenna buried beneath ancient ice, activated when exposed to enough stellar energy. If so, it would be a self-operating technology. No pilot, no transmission, just a programmed reaction to light itself. But how could that be proven? How could anyone reach an object moving at 130 kilometers per second, far beyond the grasp of any spacecraft? No one could get close. All humanity had was light, faint reflections from a distance. The more they observed, the deeper the mystery grew. As Atlas passed perihelion, instead of weakening from material loss, it stayed brilliantly intact. No decay, no dust tail, no spectral distortion. It was as if the object were encased in a material impervious to heat, something that didn't melt, didn't evaporate, didn't break. From European research centers to Tokyo's observatories, thousands of models were built to explain the impossible. One bold theory emerged. Atlas might not be solid at all, but hollow, a massive cylindrical shell lined with reflective matter, acting as a cosmic mirror. It didn't absorb energy, it resonated with it, like an instrument vibrating at the right frequency. If that was true, then Atlas wasn't just passing through the solar system. It was listening, measuring. The physics community split in two. Skeptics dismissed it as a natural anomaly, accusing others of projecting meaning onto random cosmic noise. But others pointed to strange coincidences. Why did Three-Eye Atlas travel almost exactly along the ecliptic plane, the path where most planets lie? Why did it shine brightest when its reflective face was aimed directly at Earth? And why did its light pulses align perfectly with 1/3 of the sun's magnetic oscillation frequency? Too perfect to be coincidence. A senior ESA scientist said in a confidential interview, "Science can explain anomalies, but when an anomaly follows a rule, we have to ask, whose rule, nature's or intelligence's?" The words echoed through the halls of research, mirroring humanity's growing unease. As Atlas drifted outward, its brightness faded, but the pulse remained, steady, unwavering. Like a lighthouse receding into darkness, its rhythm persisted, not in spin, but in time. At the Jet Propulsion Laboratory, teams pored over hundreds of hours of light data. A young student noticed something astonishing. The pulse intervals followed the Fibonacci sequence, the same ratio found in seashells, petals, even spiral galaxies. But here, it wasn't coincidence. The timing was accurate to the millisecond, impossibly stable for a natural process. When the report was shared internally, a quiet question surfaced once more. If someone wanted to leave a message for another intelligence, what language could be more universal than mathematics? Time passed. Atlas continued its silent retreat from the sun, slipping back into the dark. Its glow weakened, but never vanished completely. Scientists knew they were about to lose it, just like they had lost Oumuamua. No probe could catch it, no instrument could touch it. All that remained was the fading light and questions no one dared to answer. Then, in the final moments of observation, as Atlas drifted beyond Webb's tracking range, something small yet unforgettable happened. For a few fleeting minutes, its signal changed. 3 short, bright pulses, then nothing. 3 flashes. Simple, brief, never repeated. Scientists quickly labeled it solar interference, random fluctuation in the spectrum. But those who had followed Atlas from the beginning couldn't forget it. 3 final beats of light, like a heartbeat, before it vanished into the void. No one knew if it was coincidence or message. Only that after that moment, the sky fell silent again. A silence so thick, so cold, it felt as if the universe had closed a door humanity had only just glimpsed through. And beyond that darkness, where light no longer reached, something might still be moving, still watching, still carrying its own glow. A memory of the cosmos, or a message from those who have known we exist for a very long time. When Three-Eye Atlas drifted beyond humanity's reach, it left behind not just a fading streak of light, but a wound in our understanding. The final bits of data from James Webb, Hubble, and dozens of observatories around the world were gathered together, forming an incomplete map of the unknowable. And in that emptiness, where knowledge meets the edge of its own limits, new hypotheses began to flicker to life, like candles lit in a darkened room. The first, and most familiar, came from the realm of classical science, the natural hypothesis. According to it, Three-Eye Atlas might be an ancient remnant, a fragment ejected from the outskirts of the Milky Way, swept across space by the gravitational collisions of stars billions of years ago. Perhaps it was once part of a distant planetary system, orbiting a sun long since dead, leaving behind nothing but stardust and drifting winds. As stars collapsed, expanded, and exploded, debris was hurled into the void, wandering for eons until, by sheer coincidence, it passed through the same cosmic neighborhood as Earth. In this model, Atlas's strange traits, its brightness, speed, and light fluctuations, could all, to some degree, be explained through extreme astrophysics. Maybe it contains rare compounds never before discovered, or its crystal structure interacts with sunlight in ways we've yet to understand. Some researchers even suggested that, in the frozen emptiness of interstellar space, slow chemical reactions over billions of years could generate unconventional forms of energy, allowing Atlas to shine without burning. That is how the universe often works. Strange, but still natural. Yet for those who saw the rhythmic oscillations in its light spectrum, the near-perfect regularity of its signals, chance alone didn't feel sufficient. And so emerged the second hypothesis: bold, dangerous, and almost too beautiful to be true, the technological hypothesis. According to this idea, 3i Atlas isn't just a relic, but a machine, an ancient arc probe sent forth by a civilization that lived billions of years before us. It was designed to survive the darkness of time itself, needing no fuel, no pilot, only the light of stars to awaken, before drifting back into slumber between them. Theoretical physicists have speculated that if an advanced civilization wanted to explore the cosmos without direct interference, they might send out immortal messengers, devices disguised as natural phenomena, an icy comet, a rocky body, or even just a reflective shard of matter. They would transmit no signals, reveal no presence, silently observing and recording, responding through mechanisms beyond our comprehension. A few papers on Arxiv have mentioned this idea, calling them stealth probes, invisible scouts hiding under the perfect camouflage of ordinariness. Because in a universe so vast, nothing is more suspicious than what seems utterly normal. And if Atlas were such a messenger, then its silence wouldn't be proof of nature, but a strategy of intelligence. Magnetic field measurements around Atlas's orbit revealed faint oscillations out of sync with the solar wind, as if a weak electric field were self-adjusting to maintain stability. Not enough to prove anything, but enough to make one wonder. And those periodic flashes of light, if they're not a signal, then what are they? No one knows. But if someone, somewhere, were sending a greeting, they might choose the only language that can cross billions of years: light. The technological hypothesis, though unprovable, has a kind of irresistible allure, because it raises a deeper question than what Atlas is. If they once existed, where are they now? And if they sent Atlas, who was it meant for? Amid heated scientific debates, a quieter thought began to surface: the philosophical hypothesis. It doesn't speak of matter, nor of machines. It speaks of perception. According to this view, 3i Atlas isn't an object at all, but a form of observation, a cosmic eye, not sent to communicate, but to witness. It carries no message, it is the message. Perhaps the universe needs no sender or receiver, only awareness for meaning to exist. Some physicist-philosophers argue that everything in the universe is bound by the principle of observation. Particles only take form when they are seen. So if 3i Atlas is a manifestation of attention itself, then humanity's act of seeing it was what made it real. A glimpse through a telescope, a reflection caught by a sensor, and suddenly, the object became part of reality. And perhaps, somewhere out there in the dark, another gaze was looking back. In cosmic philosophy, there's a concept known as the cosmic mirror. Every civilization, once advanced enough, begins to seek itself, not by looking inward, but outward, finding in the stars a reflection of its own being. Maybe Atlas wasn't anyone's messenger, but humanity's mirror, a test of how we face the incomprehensible. That philosophical hypothesis, though elusive, carries the stillness of truth. Because sometimes the greatest mystery in the universe doesn't lie out there, but in the eyes that observe it. And so the three hypotheses, natural, technological, and philosophical, coexist, orbiting a single center: the limits of human knowledge. None proven, none disproven. Each a window cut into the night, showing a fragment of the unnameable. In the darkness of understanding, humanity gazed at 3i Atlas as if staring into a vast cosmic eye, unblinking, pupilless, reflecting the light of dead stars. Some called it the universe's candle, faint yet persistent, not to illuminate, but to remind us that amid the infinite black, awareness still exists. And perhaps, in some fleeting moment, when Atlas's light touched Earth, all of humanity became the observed. Not by an ancient civilization, nor by some mysterious machine, but by the universe itself, watching, remembering, and smiling in silence. 3 Atlas continues its drift through clouds of stardust beyond the reach of every telescope, fading into the dark. Yet strangely, after its disappearance, deep space observatories began to detect something else. A faint repeating background signal at 1.618 megahertz, almost exactly the golden ratio. No one dared to draw conclusions. No one dared to publish. Only a short note appeared in an internal ESA report dated November 17, 2025. Perhaps the universe is looking back at us through the very windows we have opened. And so the story of 3i Atlas ends, not with an answer, but with a silence that has shape. A silence like the breath of the cosmos, distant yet familiar. And within that darkness, humanity no longer asks what it is, but only wonders one thing. If the universe has eyes, how long have they been watching us? As the light of 3i Atlas faded beyond the edge of space, telescopes still lingered on the path it once traveled. Yet the void it left behind was not just an empty patch of sky, but a fracture in our understanding, a question stretching wide as the universe itself. If one messenger has passed through, how many others are still drifting unseen in the dark? Since that encounter, the world of science has begun to stir, not with grand announcements, but with a deliberate kind of silence. In sealed laboratories and closed-door meetings, humanity has started to build new eyes and raise new ears. In Chile's arid Atacama Desert, the Vera C. Rubin Observatory, the culmination of decades of effort, is nearing completion. Each night, it will scan the entire sky, capturing millions of images, tracking motions so subtle that no one has ever noticed them before. It won't just be searching for asteroids or comets, but for things beyond the map of our solar system. Interstellar wanderers like Atlas, drifting between the stars, belonging nowhere. With Rubin, for the first time, humanity will be able to watch the night sky change, as if the heavens had become a slow-motion film, each point of light telling its own story. Every one of those lights could be a rogue planet, a shard of a dead star system, or, if we're lucky, a message sent long ago. Half a world away, the European Space Agency is preparing the Comet Interceptor, a mission unlike any before it. Instead of chasing a known comet, it will wait for one that hasn't yet appeared. The spacecraft will sit poised at the Lagrange point, a gravitational balance between Earth and the Sun, ready to launch the moment another interstellar visitor is detected. For the first time in history, humanity won't just watch the universe. It will lie in wait for it, like a sentinel before the gate of infinity, listening for the next knock. Instruments like Rubin and the Comet Interceptor are just the tip of the iceberg. Beneath them lies a deeper layer, where the universe is not only seen, but heard. The SETI Institute, after years of quiet, has launched a new project, real-time tracking of radio signals, not just from suspicious exoplanets, but from any object passing through the solar system. Whenever a new point of light is identified as interstellar, dozens of radio observatories across the globe synchronize instantly, sweeping frequencies from 1 to 10 gigahertz, a range once called the quiet zone of the cosmos, where natural signals rarely occur. But it's within that quiet that humanity hopes to hear another kind of breath, tiny, steady, and deliberate. The data are processed by quantum AI, trained to distinguish random cosmic noise from structured signals. And sometimes, within billions of lines of data, a faint repeating frequency emerges, a pattern that seems intentional. But when checked again, it vanishes, as if someone had just flipped a switch. Scientists call these events echo nulls, the echoes of emptiness, where a signal appears only to prove that someone might be listening. Humanity watches and listens, endlessly, while the heavens remain silent. Yet within that silence, something is shifting. Each year, new telescopes discover hundreds of objects on open-ended trajectories, visitors from elsewhere, perhaps millions or even billions of years old. Physics models suggest that, at the current rate, every few years an object like Oumuamua or Atlas passes through Earth's neighborhood. Which means, if these objects are messengers, then the universe has never stopped sending letters. It's just that we've never learned to read them. Meanwhile, in Switzerland, CERN quietly collaborates with quantum physics centers to simulate the behavior of matter in interstellar conditions. In near-perfect vacuum chambers, they bombard frozen samples of CO2 and NH3 with ultraviolet radiation and high-energy particles, recreating the environment of Atlas. The results are strange. In some cases, these compounds generate weak, spontaneous electric currents, a phenomenon never seen in ordinary comets. If true, Atlas's self-activating energy might not be magic at all, but the result of an undiscovered physical mechanism, a door cracked open between classical and quantum worlds. In Japan, the Subaru telescope on Mauna Kea has been upgraded with rapid spectrum detection, allowing scientists to break the light of interstellar objects into thousands of fine bands. Astronomers believe that if any artificial interference exists, like reflective crystal structures or synthetic energy sources, it would leave traces there. And sometimes amid the cold lines of data, they find light pulses too regular to be random. Not enough for proof, but enough to keep someone awake through the night, staring at the stars and wondering, could this be a gaze from long ago? Science, like the universe, never stands still. After Atlas, humanity no longer searches to confirm, but to understand the silence itself, and why, among billions of stars, there isn't a single reply. A paper in Nature Astronomy once wrote, "If the universe truly teems with life, then its silence is the voice of caution." Perhaps other civilizations are hiding, quietly watching, because they've learned that light can be the most dangerous invitation of all. And perhaps, as we build more eyes to see, we too are becoming the ones being watched. Every signal we send, every radar pulse that sweeps the sky, is a confession to the cosmos. We are here. Machines like Rubin, Interceptor, Webb, and SETI are symbols of longing, but also of prayer. A prayer that loneliness is not our destiny. A hope that somewhere in the dark, someone is looking back. In the stillness of space, a voice seems to rise, questioning time itself. We build more eyes, we raise more ears. But the real fear isn't seeing nothing, it's seeing too much. And as the sky grows ever brighter with countless electronic eyes, perhaps the one truth humanity is still unprepared to face is not that we are alone, but that we never truly were. In the midnight expanse of space, 3i Atlas faded away like the last breath of a candle snuffed out by the wind. Its orbit stretched beyond the sun's reach, slipping into a shadowy realm where light no longer had the strength to touch it. Earth, with its blue oceans, restless winds, and silent mountains, spun back into its everyday rhythm. But for those who had seen Atlas, what lingered wasn't an object, but an emptiness. A question suspended between the sky and the mind. Even as telescopes were powered down and data archived, humanity hadn't truly stepped away from that moment. There was something about 3i Atlas that made people realize the universe isn't just something to be observed, but a mirror reflecting our own existence. A frozen stone, traveling for billions of years through endless space, crossing the invisible pull of stars, moving through time like a living memory. It knew no borders, no clear beginning, no certain destination. And as it passed by, it left behind one of the deepest questions humanity has ever faced. If a stone can journey for billions of years across the void between the stars, what is it that keeps us tethered to this small planet? Since ancient times, people have looked up at the sky, believing the universe to be the dwelling place of gods, the dome of fate itself. But now, when we look up, what reflects back is not myth, but our own smallness. We know we're just a fleeting tremor in the flow of space-time, a single breath in the 13.8 billion-year symphony of the cosmos. In its silent journey, 3i Atlas became a symbol of absolute freedom. A stone unbound, unowned, drifting through the infinite, beyond the reach of gravity and time. And yet, as people watched it vanish, they saw themselves confined to another kind of orbit, the orbit of understanding. We send out probes, launch satellites, build telescopes, but all of it is like throwing stones into a deep ocean, only small ripples in an infinite sea of knowledge. Atlas reminds us that some things can't be measured by equations or captured by technology. Perhaps its silence is the language of the universe, a language we've forgotten how to hear. Physicists may call it debris, an ancient comet, the product of distant gravitational forces. But in the depths of thought, it becomes something else, a symbol of awareness, that the universe isn't just expanding physically, but expanding within our own minds. Every time we witness something we can't understand, the edge of what we call knowing slips a little farther away. Maybe that's the true message of Atlas, not a signal from another civilization, but an invitation from the unknown. An invitation to keep asking, to step out of the safe boundaries of old knowledge and reach into the emptiness where the infinite begins. A philosopher once said, "The universe has no meaning until someone looks at it." But when humanity looked at Atlas, perhaps for the first time, the universe looked back. In that gaze, they reflected each other. On one side, a wandering stone without memory. On the other, a creature that dreams. Between them hung a single, fragile thread, curiosity. That curiosity is the only flame we have to push back the darkness of not knowing. It drives us to launch ships like Voyager, carrying golden records that greet the cosmos. It drives us to look at the pinpoints of light and believe there is life among them. And it is also what frightens us. For every question answered opens a deeper layer of uncertainty. Perhaps Three-Eye Atlas doesn't carry proof of someone else, but proof of ourselves, that humanity has not stopped searching. In a cold universe, that act alone, seeking without knowing what for, is the truest evidence of life. As Atlas' light disappeared, telescopes still tracked it, as if humanity couldn't accept something passing by without leaving a farewell. But the universe doesn't need goodbyes. It only needs to exist. We, with our eyes full of longing, are the ones who need meaning more than anything else. Maybe Three-Eye Atlas is just nature, a nameless shard flung into the dark by dying stars. But in the way it made us pause and look up, it became a witness to meaning. Because sometimes, what makes an object extraordinary isn't its nature, but the way we see it. In an indifferent universe, we are the only beings who tremble at the beauty of a departing comet. And that feeling, fragile, irrational, but piercingly real, is proof that we are still alive, still capable of wonder, still searching for ourselves in the mirror of the stars. When Atlas vanished into the night, some said the universe felt a little smaller. But perhaps the opposite is true. We had grown larger. In the instant of seeing something beyond our reach, we understood that knowledge isn't a destination, but an endless journey of consciousness. If a stone can carry the history of the universe within it, then the gaze of a human upon it carries the future of awareness. A future uncertain, borderless, but full of hope that each new mystery will light another corner of the dark. Three-Eye Atlas has left the solar system, crossing the threshold where the solar wind fades to nothing. It will drift on for millions of years, silent and enduring, like a memory etched into the fabric of space-time. One day, another civilization may see it, and they too will ask, as we do today, who sent it? That, perhaps, is the greatest wonder, not the answers, but the continuation of the questions. From civilization to civilization, from light to darkness, curiosity is the only language the universe truly understands. And so, as humanity keeps turning its lenses to the sky, waiting for another sign, another passing object, the voice of the story softens like a final prayer of knowledge. Perhaps Three-Eye Atlas is only a stone, but it forces us to face our own limits. Perhaps it is only nature, but it may also be a message that our curiosity is the thread connecting the stars. The night sky is silent, but no longer still. Because now, humanity knows that every time we look into the universe is looking back. And as we continue watching distant objects, perhaps somewhere, in the dark, someone is watching us too.